Isosceles and equilateral triangles. Now you may be asking yourself, now wait a minute, Ariano. I learned all this stuff back in elementary school. An isosceles triangle is any triangle with two congruent sides. An equilateral triangle is any triangle that has three congruent sides. And you might be telling yourself, and I even learned about a scalene triangle where all three sides are different. And I'm not here to tell you any of that is incorrect. In fact, that's very, very true. But the only reason we point out today, which frankly, it does center on those same basic premises. They do not go away. So don't think that you have to learn anything new. This is going to be how we're going to apply all of that geometrically and how the math comes in. Now, in the grand scheme of things, all this does is it makes sure we can combine like terms and solve for a variable. It's really a very simple, straightforward thing. But if we don't know what we're looking for, we're not aware of the things that we could do with it, then we just might not be prepared for what we need to be prepared for. So that's what this is about. Don't think it's going to be crazy. So, yes, just as a reminder, isosceles triangle, a triangle with two congruent sides. An equilateral triangle, a triangle where all of the sides are the same. All right, great. All of that's legit. But because we typically just associate the side lengths, we tend to forget that there are other traits that come with both our isosceles and our equilateral triangle. And that's where the math comes in that we kind of get shaky with. So let's just start off with our isosceles triangle. That's an isosceles triangle. An isosceles triangle has two congruent sides and one side that is not congruent, obviously. But while the congruent sides, which we call the legs, are always congruent, and then the side that's not congruent, we call that the base. The reason that's important is because we also have angle relationships that come with our isosceles triangle. It's not just the sides. The sides are a thing, yes. But, yes, there are two congruent sides, but there's also two congruent angles over there as well. And specifically, they're what we call the base angles, the angles that touch the base. That's why it's important to know the difference. The two angles that touch a leg and a base. How about that? Because the other one's called the vertex angle, where the two legs meet, where the two congruent sides meet. That's the vertex angle. We seldom ever pay attention to that. I mean, we do, but I mean, it's not one of the two angles that are congruent. So it's kind of just one of those things where we're just... the angles part is the part where everything gets everyone forgets. For some reason, everyone knows, yes, isosceles triangle, two congruent sides. Right. But you also need to remember two congruent angles. And they're the base angles. So when you put all that together, that's where the math comes in. Again, is it hard? No. No. It's actually very straightforward. Again, math we could use the two congruent sides and two congruent angles to set up basic equations like this. We note, first of all, the big thing is we have to note it. Oh yeah, that's an isosceles triangle. Now, why do we know it's an isosceles triangle? Well, because in that triangle right there, I see the arc marks denoting that there are two angles that are congruent. Okay, well, we know an isosceles triangle has two congruent sides and two congruent angles, and only one of those has to be true to classify it as isosceles. So this is one of the things that I like. This is why we mention this. We may not initially, because we always have in our mind, isosceles triangle, two congruent sides, that's it. Well, just showing two congruent angles also tells us that it is an isosceles triangle. So that also tells us that those two sides, which are marked with 19 plus x and 7, are also congruent. So the math is just, oh, okay, 19 plus x, that side, is equal to the 7 side. So 19 plus x equals 7. Subtract 19 from both sides, and we have an x as a negative value. That's all. That's all this turns out to be. But if we don't even recognize that to be an isosceles triangle, we don't get to the easy math part. So that's why we go through this today. Not to make something overly complicated. It's just, this is the thing we're less familiar about. I could put the tick marks there and you'd have it, no problem. But the arc marks, the two angles part, is very easily forgotten for some reason. I don't know why, but it has been in my experience. So that's why we're using this today. Okay, cool. I know it's an isosceles triangle. Boom, set up easy math. Buble out the way. That is another way where the easy math we know can sometimes be like, what do I do? Now, I have to note it's isosceles. This one's easy because I see the 2 tick marks. So the 2 tick marks tell me the 2 sides are congruent. Aha, isosceles. All right. What now? Well, this is where now that we have to recognize, oh yes, an isosceles triangle has 2 congruent sides and 2 congruent angles. And specifically, they're the base angles, the ones that touch the leg and the base. So these 2 angles right there are congruent. And again, if I didn't know that, I might not recognize that, okay, this angle here, and then the 2 base angles. So if I might not know what these base angles are, I just at least know that they're the same. So I could say, okay, well, this angle at D, I'll just quantify it as X. I'll have to also quantify this angle at F as also X because they're the same. And then I bring in the triangle sum theorem. Yes, the fact that it's an isosceles triangle tells me those 2 angles are congruent, but I also know all the angles in a triangle add to 180. So this is one of those examples you want to look out for. I may have just told you the 1 vertex angle, and you might initially just go, oh yes, I know all the angles in a triangle add to 180. But you might not recognize that, oh, I don't have enough information. I don't know the angle at D, I don't know the angle at F. If only I knew them, I could solve, or I knew one of them, I could then solve for the other because all the angles add to 180. But because it's isosceles, you know those base angles down there are the same. So you could just mark them as X's and say, oh, okay, the 2 base angles, we'll just call them both X, plus 22, the vertex angle, equal 180. Aha! Subtract 22 and solve for X. Boom! Now that's the type of math that we use in this part of the class. It's very combined like terms. But if you don't know what you're looking for, what the properties over there tell you, then you can't get to the easy math. So we got to get to the easy math. So again, this is why we bring up that small little thing that, yes, you know. Use what you know and get to the easy math because of it. Okay. So, let's see if you paid attention. Why don't you try one? Pause the video right here, and let's see what you get. Okay. Now, instinct should be coming off, even if you didn't know, let's be honest. Even if you didn't know that, oh, it's an isosceles triangle. Aside from the fact it says isosceles triangle right there. But okay, and there are tick marks, so the 2 sides are congruent. And what should happen is, okay, it's isosceles. There's 2 sides congruent, so those 2 base angles are congruent. But worst case scenario, just wouldn't it kind of just make sense to set those equal to one another? I'm just throwing that out there. Do something. Even if you didn't know, do something. Set them equal to one another is one of the main things that we do in geometry. Really, it's just set equal to one another, or they add to 180. Those are really the 2 biggest things. A lot of other things happen, but I'm just throwing that at you. So what we should do is aha, it's isosceles, there's tick marks that tell me so. I will then say that because it's isosceles, it has 2 congruent sides and 2 congruent angles. Those 2 congruent angles are the base angles that are shown over there at G and J. I don't know why I'm whispering. So 3x equals x plus 44. I solve for x, and x is 11. Here's the other thing I'm going to point out. And I've mentioned this many times already. Just be careful what you've been asked for. Now that says solve for the measure of angle G. It doesn't say solve for x. And I'm the person where if I had a multiple choice test, and this was a multiple choice problem, I am the person who one of my answer selections would be 22. But your answer is not going to be 22 because I didn't ask you to solve for x. That says solve for g. So you need to take that x and plug it in. Remember, this isn't that hard. It's really very simple. I'm not trying to make it hard. But you just need to be careful with stuff. Take your time. This should be simple. Try another one. Pause the video. This one you should really have paid attention. Why should you have really paid attention? Because we pretty much did the exact same thing earlier, except I think the vertex angle is 22. Again, mode of thought should be like, aha, it's an isosceles triangle. I know that because there are two congruent sides that are clearly marked. An isosceles triangle has two congruent sides and two congruent angles. The base angles, in fact. The angles at G and H. So if I know angle at G equals the angle at H, and I just label them whatever, in this case I just said X because that's what we typically do, I can now go back to the other old stuff I know. Oh yes, all the angles in a triangle add to 180. So 48 plus 2 x's equal 180. I solve, and x is 66. Is x what I was asked to solve for? In this case, yeah, actually it is, because x represents the measure of the angle at h, which is what I was actually asked to solve for. So that's good. Not always going to be, though. Okay. One more. Pause. Go. Yes. You're just going to set them equal to one another. That's correct. Again, it's an isosceles triangle. I know that because there's tick marks. An isosceles triangle has two congruent sides and two congruent angles. The base angles, which in this case are the angles at N and P. So those two expressions, 6y and 8y minus 16, are set equal to one another. I solve for y. Was I asked to answer y? No. I was asked to solve for the measure of angle N. So I'll take that value for y and plug it in. Don't let that get you. Because again, if this is a multiple choice problem, yeah, 100% one of the answer choices would be 8. Gotta make you think. Gotta be right on it. Alright. The only other triangle that we mentioned already, well, we did, I guess mention scalene. But like the other one that's going to have any sort of properties that we're going to be associating with is the equilateral triangle. Now you're all like, well, wait a minute. I already know all the angles in all the sides in an equilateral triangle are congruent. And you're right. But an equilateral triangle, as it says down at the bottom, is also equiangular, which means all the angles are the same. So not only do all the sides equal one another, and in this case, if you don't get ahead of me, yes, you're right, of course. Like, oh, yeah, okay, if it's an equilateral triangle, I know all the sides are equal, so I set expressions equal to one another. That's exactly right. But the equiangular part is also a thing. Because it's not so much you're going to set angles equal to one another, which I guess you could. But if you have three angles that are all the same, and you know all the angles add to 180, then if you have an equilateral triangle, which is also equiangular, 180 divided by 3 is 60. All the angles are 60. So actually, you're going to get something that looks like that. And you're going to need to know what to do. And you might not initially, but the thought process, again, should go like this. Oh, it's an equilateral triangle. I know it's equilateral because there are tick marks here that show me all the angles are the same. Now, initially, if this was like at the very beginning, all you know is all the sides are congruent. And that degree measurement expression right there doesn't really help you. But it's an equilateral triangle. Aha! Also an equiangular triangle. So all the angles are the same. And because there's three angles and you just do 180 divided by 3, all the angles equal 60. So that expression right here, you just set it equal to 60. That's all you do. Solve for x. And in this case, I asked you to solve for x, so you're literally done. But if you don't know that, you don't know what to set that equal to. So again, prior to today, you might have forgotten this part. Is it hard? No, that math is super easy. You can do that. Even by like terms, you've been doing that since elementary school. You just need to know the process to go through. Ah, it's equilateral. So all the angles are 60. Set that equal to 60. This is probably the thing you would be expecting, but maybe not presented this way. Because again, normally, before today, most of the times we would just think about equilateral triangles being all the sides are congruent. This has no markings of sides. But it has all markings of angles, and they all have one arc mark. So this goes back to all the angles in my triangle are congruent. Oh, it's equiangular. Okay, if it's equiangular, then it's also equilateral. So that's our, if we're looking for a flow chart, all the angles are the same in my triangle, so all the sides are all the same in my triangle. You'll notice, by the way, like it goes with the isosceles triangle stuff, and there's other things that I'll just get into, but we can reference about like the greatest sides opposite the greatest angle, the small sides opposite the smallest angle, all that stuff. Like it all fits here too. So hold on. First thing, the easiest way to remember is that if there's 3 congruent sides, there's 3 congruent angles. If there's 2 congruent sides, there's 2 congruent angles. That's isosceles. And if none of them are congruent, then well, that's scaling. We don't really even talk about that because there's nothing to really do with it. This also abides by biggest side opposite biggest angle, smallest side opposite smallest angle. Oh wait, all the angles are the same, so all the sides must be the same. That's how we know. That's how it all fits. And by the way, that's the same thing that happened with the isosceles triangle. The 2 legs are directly opposite from 2 base angles which are congruent. Well, if the sides are congruent, then the angles are congruent. It's almost as if it's all supposed to link. If only I was a good enough teacher to actually like structure it so that it all kind of meshed together. Anyway, those 2 sides are the same. Set them equal to one another. Ta-da! Solve for y. Am I done? Yes, it says solve for y over there. So again, like, I don't want this to come across as like, it's so simple, but it kind of is. Where people get screwed up with is when they just don't pay attention. Don't be that person. Just small little extra bit of just a time. Just a little bit more time. And you got this. So try one. Pause the video and see what you got. Okay, flowchart goes, all the angles are congruent, so all the sides are congruent. Yes, this is an equilateral triangle, even though I've only got arc marks. Even though only angles are denoted, yes, it's an equilateral triangle. So the 2t plus 1 equals the 4t minus 8. That is correct. You solve for t. Cool, t is 4.5. Was I asked to solve for t? That says find JL over there. So you gotta plug it in. And I'm whispering again for some reason. I don't know why. See? Not that hard. Just focus, pay attention, take advantage of the easy stuff. Because we're going to use all these later. A lot of them, by the way. So, of course, if you have questions, don't hesitate to ask. You know where to find me. Take advantage of this stuff. Be good, y'all.